can zoom and cast all at the same time. We'll see how it goes. All right, so again, when you walk in each day, you'll see a schedule of what we're going to be working on for the day. You will be able to go into Schoology and look at your answers from the previous day's assignment. I will have a warm-up up here, a couple questions for you to do as a warm-up. And then also this BP, this stands for board problems. Okay, so you can see this BP. So it doesn't matter for these ones, but previous day's homework, say look at 2, 11, 16, and 18. So there's 4 opportunities for you to go up to the board, and you can pick any of these sideboards or anything. You could even pick a front board. Okay, don't be scared to come up here. It's not that bad. Okay, and you would write like number 2. You'd write the problem out. You can bring your work up. Okay, I'm not putting you on the spot. It's not a quiz or anything. And you can look right at yours. Okay, this is how I solved it. Here's your answer. Once these are all done, all the board problems are done, warm-up's done, everybody's checked over the answers. You could probably do it right from your seat. I won't have you come back up. Say, okay, explain how you did number 2. And you'll say, okay, this is what I had to do. I had to move this to the other side. I had to take the square root of this piece, blah, blah, blah. This is where I got to the answer. Okay, this is for everybody in the class, but it's also for me. This is just a quick snapshot to see, kind of get a gauge if we're understanding how to do these problems. Okay, so it's not an assessment. I'm not grading you on your board problem. If you make a mistake, no big deal. Okay, I'm not going to criticize you if you made a mistake. I actually want to see a mistake being made, because then I can help you correct it, and it might be a mistake somebody else made. Say, okay, right there, all you did, instead of subtract, you added, or vice versa, or whatever. If I can see your mistake that you made, that's going to help you out, and it'll probably help somebody else out in the class. Okay, so don't feel intimidated if you make a mistake. Okay, I make mistakes, no big deal. Okay, math, we learn from our mistakes and we continue on. So, a lot going on to start class. We're going to do board problems, we're going to have a warm-up, and also kind of the schedule for the day. So let's take a look at this one. So this is getting into exponent stuff. And all we are doing here is simplifying. This is not solving. You can only solve if there's an equal sign. All we can do is write this out in simpler form. So for example, if I had a really easy one like 3x squared plus 7x squared, I can combine that to be 10x squared. That's simplifying. That's not solving. That's not doing anything to figure out what x is. All we're doing is rewriting in simplest form. So this one, 14x to the 7th, y to the 9th, all divided by 7x to the 4th, y to the 11th. Well, first thing I would do, I would write this by separating everything into its own radical. All right, this is true. On the top, it's saying 14 times x to the 7th times y to the 9th. It's all being multiplied. And on the bottom, it's all being multiplied. So I can rewrite those as separate pieces, still with division, but multiplying across. But now I can start to simplify. Well, I know 14 divided by 7, that's really 2. X to the 7th divided by x to the 4th. What is x to the 7th divided by x to the 4th? Max, what do we do with those? Subtract, okay? Because really, x to the 7th, if we were to list it out, it would be 7 x's all being multiplied together. But then on the bottom, we'd have 4 x's all being multiplied together. And if I have x over x, that's really 1. So it's 1 times 1 times 1 times 1 times 1 times x cubed. I think I might have done 1 too many there. Okay? But really, what we're doing is subtraction. So 7 subtract 4 is 3. And it's always top, subtract the bottom. And then the last one, y to the 9th divided by y to the 11th. Well, that's y to the negative 2nd. But never write a negative exponent in your final answer. How can I rewrite y to the negative 2nd with a positive exponent? Evan, you remember? Correct. I can move that down here, and that would be y squared with a positive. So exponents, positive or negative, like you can move those around. If it's a negative, you can bring it down to the bottom. If it's a negative on bottom, bring it up to the top and make it positive. Okay, so simplified, this big mess, 14x to the 7th, y to the 9th, all of that simplified is really 2x cubed divided by y squared. And if it helps to write it all out as separate fractions like that, and you can actually see what's going on, do it, okay? I don't care how many steps you have in between, do as many steps as you need to be able to get to that final answer. All right, this one is really 3/9 times, as a fraction, I could write this as a over 1 times b over b. So 3/9 simplified is 1/3. A over 1 is still a. B over b is just 1. So I don't have to write 1/3 times a times 1. I could just write it as 1/3 a, or I could also write it as a over 3. Okay, either way, I don't mind. Whatever way, still true. Okay, and then the third one here. Exponent properties allow me to bring this 4 to each term in the numerator. So this is really 2 to the 4th, x to the 4th. I can think of 2 to the 4th over 1, and then this would be x to the 4th over x. All right, the exponent only applies to both terms in multiplication or division. If this was 2 plus x to the 4th, that is not the same thing as 2 to the 4th plus x to the 4th. Okay, you can't do that with addition or subtraction. But with multiplication or division, you can do that. All right, 2 to the 4th. What is 2 to the 4th? 2 times 2 times 2 times 2. So this is 16 x 4 minus 1, 16x cubed. So this stuff was kind of getting into the buildup where we should be. We should know these exponent properties. So this warm-up was the intention. This isn't the lesson for today. This was just a warm-up that we should be comfortable with these exponent properties. That we subtract if we have division going on. Exponent is going to apply to the 2 and the x. How we can simplify. All right, and then again, these board problems, and then I take a look at those, work through these board problems. If there's a couple that need to work out, you don't have to write this down, but this would be the board problems. I'd also work those out if I saw a mistake on one. Okay, and then we'll get into actual today. So today, 6.1, dealing with roots and radical expressions. Okay. So if I wrote a to the n, that n is my exponent, I could also write it as a to the nth root of b. This whole statement here, a to the nth root of b, the nth root, I wrote it as a radical. That n is up there, that's called the index position. The nth root of b would look like this. So n would be my index. My radicand is what that piece is under the radical, equals a. So going from exponential form, a to the n equals b, is the same thing as the nth root of b equals a. All right, some keys when dealing with the nth root. If n is odd, then there is one real nth root. All right, and this idea of real, we're only working with real numbers. We're not working with imaginary numbers at all. So if n is odd, if it was a cube root or a fifth root or a 13th root, I only end up with one real nth root. Second one, if n is even and b is positive. So this could be like square root of 16. This will probably be the only time you see me write a 2 up in that index position for a square root. If there's not anything in that index position, it is the square root. Okay, you automatically assume that is, there's a 2 there even though it's not written. So the square root of 16, when I work this out, really this is saying, well, what squared equals 16? Okay, so this goes back to the very first statement, from radical form to exponential form or vice versa. Okay, if n is even, b is positive, then there are 2 roots, and so this would tell me then that x would be plus or minus 4. So if I put a negative 4 squared, that's 16. If I put a positive 4 squared, that's 16. So it's saying if n is even and b is positive, then there are 2 real roots. If n is even and b is negative, so say we had the square root of a negative 16, that's saying that x squared is going to be equal to negative 16. There is not a value for x that I can put in there to square and end up with a negative 16. So that's why it's saying there are no real nth roots. We did all that work with imaginary. If we were working with imaginary, we know then that this would be 4i. But we're talking real only. Okay, there's nothing I can square to get a negative number, so that's why it's saying there's no real nth roots. All right, so here we go. Find all the real square roots of each number. And so number 1, that's actually 0.16. Okay, that decimal is not a repeat. Problem 1 or example 1. So this is saying the square roots, and I'll put that 0 in there as a placeholder so that we're clear that it's 0.16. All right, just like that last slide told us, if we have an even nth root of a positive number, that we're going to have 2 solutions, so that plus minus 0.4. Okay, because you can, again, you're trying to think, okay, what squared is 0.16? Well, I could put in there a positive 0.4, but I could also put in a negative 0.4 and still get 0.16 as a final answer. Okay, again, all these are square roots. So square root of negative 64, and we're trying to find the real. Well, I can't do an even root of a negative number, so this would be no real roots. And then square root of a fraction, I have the square root of 1 over 49. I could really write that as square root of 1 divided by square root of 49. All right, I can break that up and take the square root of the numerator separately and the denominator separately. Square root of 1 is 1. Square root of 49 is going to be 7. But again, we have to keep this plus minus here because really what this is saying is what squared equals 1 over 49. I could do a positive 1/7, but I could also do a negative 1/7. Okay, so even root with a positive number always include plus minus. All right, cube roots. So find all real cube roots of each number. So the cube root of negative 1,000. So what can I multiply 3 times? So what cubed equals a negative 1,000? Well, I could do that, okay? Because I could have a negative times a negative, that's positive, but times a negative again will give me my negative. And so I know this will equal negative 10. So with odd roots, I can get a negative number as an answer. There's no plus minus or anything going on with this one. This is it. Second one, this is 0.008. So if you want to put a leading zero in there of 0.008, just so you don't miss that decimal point. So what can I cube to end up with 0.008? This ends up being 0.2. And then the same here, cube root of 1 over 27. Well, I can write that as the cube root of 1 all over the cube root of 27. What times what is 27? Is 3. So this is 1/3 without any plus or minus or anything. It's just 1/3. Okay, let's do another one, little set. So what is each real root? And these ones will only have one answer or no answer. Okay, so for the first one, can I take the cube root of a negative number? Is that possible? Okay, so it's saying, okay, what can I multiply by itself 3 times to get negative 8? And this would be negative 2. All right, so with an odd number as a root, we can end up with a negative answer. Now, the fourth root, to end up with a negative 16, that's saying x to the fourth equals negative 16. That's not possible. There's nothing that I can multiply 4 times to end up with a negative number. Example 3 here, or part 3, this gets into order of operations. So really my radical here is going to be positive 49. So it's negative 7 squared, which is a positive 49. And I want to take the square roots of this positive 49. And so that would end up equaling 7. This one, we do the cube root of 8 all over the cube root of 27. Becomes 2 on top and 3 on bottom. All right, so there was a lot of examples on if you have an even root or if you have an odd root, what's going on with it. Now let's get into simplifying radical expressions. So we have some big mess underneath a radical symbol. This gets back to kind of simplifying. If I asked you to simplify square root of 27. So remember, if we had square root of 27, well, we could write that as square root of 9 times 3, which is square root of 9 times square root of 3. So that becomes 3 root 3. So what we were doing in Algebra 2A is we were trying to factor out a perfect square from these. That's the same idea that we're going to be doing when we have a bigger expression under a radical. Okay, this is a square root. So I want to write this as values squared. So instead of 16, I'm going to write 4 squared. X to the 8 really just means 8 x's listed out, or 4x squareds listed out. Because remember, x squared times x squared, you just add the exponents. That becomes x to the 4th. So x squared times x squared times x squared times x squared is x to the 8. So this is still equivalent. We're not solving, it's just making it equivalent. Now, I could break these up, and I could take the radical of each one. So I could do this. I'm not going to write them all out. But I could do a radical on each one of those. So the square root of 4 squared, that's easy. That just becomes 4. Without any radical symbol or anything. Square root of x squared, that's just x. And so now I have 4 x's with no radical anymore. So square root of x squared is just x. So final answer on this would be 4x to the 4th. The idea is it's a square root, so I'm trying to make everything under there a square. Second one, I want to make everything under there a cube. And so I could say an a to the 6, I could say a cubed times a cubed. And instead of b to the 9th, I could say b cubed, and b cubed. So if I cube root each of these underneath it, all I end up with is a times b times b times b. So this becomes a squared b cubed. I could do it with a 4th root. So I would write this as x to the 4th, x to the 4th. And I could write this with 3y to the 4th. So now I'll end up with is x times y times y times y. X squared y cubed. All right, but the idea, whatever your index is, you're trying to make your radical have that exponent. Fifth root. What raised to the 5th power is negative 32? What number can I multiply by itself 5 times to end up with a negative 32? Joel. There we go. So instead of saying negative 32, I could say negative 2 raised to the 5th power. Just like in the first one, instead of saying 16, I could say 4 squared. And then x to the 15th, well, that's x cubed, or I'm sorry, x to the 5th 3 times. X to the 5th, x to the 5th, x to the 5th. So this just becomes a negative 2 times x times x times x, which is negative 2x cubed. All right, and then last slide. So find 2 real solutions to each equation. Now we're trying to figure out, okay, what is x? What x value can I raise to the 4th power and I end up with a negative 81? All right, so if we wrote it in radical form, this is the same thing as the 4th root of 81. But we need to be thinking of these both interchangeably. My mind drifts more towards the exponential form, x to the 4th equals 81, like the earlier problems when it was a radical, I wanted to rewrite it in exponential form because it's easier for me to see in my mind, okay, what raised to the fourth power equals 81? Well, I know x could equal 3, but it's a plus minus 3 because of that even 4 as the exponent or as the root. If you put in the fourth root of 81 in your calculator, it's only going to say 3. This is where you have to be smarter than your calculator, okay? Yes, it's 3, but because it was an even root, it's the plus minus 3. Same thing here. This is really the square root of 0.49. So if I do this in my calculator, it will tell me 0.7, but because it was an even, it's that plus minus. So like I said, in my mind, I always think of them as exponential. If they give it to me as a radical, I think of it in my mind as an exponential, or I might even write it on my paper as an exponential, solve it that way, because it's easier for me to remember, okay, what squared equals 49? Well, I can do a positive or negative and square it. What to the fourth equals 81? Well, I can do a positive or negative. Odds don't work that way. Odds will stay negative. Evens will always have that, okay? So if you introduce that even root, you have to have a plus minus to it every single time. If it's the 16th root of something, your answer will be plus minus. If it's the 182nd root, there will be a plus minus every single time. Okay, all right, so your homework. I'll leave this up here. Page 364, 11 through 25 odds, 26 through 29, okay? When you are doing your homework, write on there that this is 6.1 or something. Because this will help you and it will help me to identify, okay, these are the problems for 6.1. Because if you go back, or it's 2 weeks from now, and I have a missing assignment, and you are like, well, which one is that? And all you're looking at is numbers, you're going to have to cross-reference that with Schoology and try to determine. But if you write in your notebook right here from the very start, okay, this is 6.1, these are the problems that go with it, it's easier for you to look back, and it's easier for me to see if you have a missing assignment. Because if you just give me problem numbers and you say, well, that's 7.3 homework, I don't have those memorized. Okay? Textbook screenshots are in Schoology, so in today's folder. If you want a hard copy, just come up and tell me. I'll give you a hard copy. You can have it for the entire term. And then submit this assignment via Schoology. So take a picture of it with your phone, submit it via Schoology, and I'm going to look and make sure you submit before the start of class tomorrow. When we start class tomorrow, we'll have a warm-up. You'll be able to look over your answers, and there'll be some board problems. So tomorrow will be the first day to look at doing some board problems.